Okay, in this reaction basically we have to give the product after aldol. No, this time this is Claisen after the Claisen condensation reaction. So we have to give the product after Claisen condensation. So let us copy this one. So first A is this. So you have molecule is given. Now of course one has to take two molecules of the same compound, and then one can give the product after Claisen condensation. So this molecule and the base this time is OMe minus and solvent is CH3OH. You see this part of the molecule is OMe, that is the leaving group is OMe, and the conjugate base that I am taking, that is also OMe minus. So let us write product in this reaction. What you will have, you have to take two molecules. One molecule I have written on the top, I am writing the next molecule, and then what you will do is OMe minus will take alpha hydrogen. So from here you can take H plus and then you can form a carbon ion. So this is the carbon ion you will generate. Now in the next step, this carbon ion can attack here, and in the same step this will open, and I can write the final product. What will happen, this minus will return back and this will go. So you can write this carbon and this carbon connected. So after this reaction you can write the product something like this. So you will have CHMe, Me, and here you have CH2. So you have CH2, and then you will have C double bond O. And now this C double bond O is connected with this CH, and one side of CH is COO, Me, and other side of CH is this CH, Me. So this is the final product you have. Now we have to write product after condensation, that is I have to lose some molecule. So we have lost a molecule from here, that is OMe, and that this will take H plus 2. So in that case I have basically lost a CH3OH. Basically there is a mistake, you see. In this case you have 1, 2, 3 carbon only. Now I have written 4 carbons, so there will be no CH. Are you getting or not? So this is the final product. If you write in bond line diagram, you can write the same compound. So let us write in terms of bond line structure, CH, CO this side will have OMe. So I am converting the same compound in bond line diagram. So here you will have this, and this side you will have CH2, and then CH, and then you will have Me. So this is the product you have. In terms of bond line of diagram, I can write something like this. Now let us discuss the next part. So B part you have. So this part you say we have this, and this time COOMe, and then you have this and this, and again you are treating with OMe minus and CH3OH, and we have to write product. Again we have to lose one H plus. Now from here if I lose one H plus and attack here, so this is my leaving group. So the things are very easy. So what we will do is so let me do, so this is intramolecular Claisen condensation. On the same molecule I am losing H plus and it is attacking on the same molecule. So you can say this is the intramolecular Claisen. So this is an example of intramolecular Claisen condensation. So if you lose one H plus, you will have OMe here, and this side will have minus carbon ion, and here you have a lone pair. You can put this lone pair here. Now this lone pair can attack on this carbon, this comes back, again this goes and OMe goes. So if you follow those steps, I can write, if you wish I can write in 2 steps. So this carbon connected, so you will have a 5-membered carbon ring, 1, 2, 3, 4, 5. So let us make a 5-membered ring. So So this is a 5 member ring, 1 2 3 4 5. So let us number this 1 2 3 4 5. No, this is a 6 member ring. So basically this is a 6 member ring. So this is not a 5 member ring. So you have a this side 6 member ring and this side also you have a 6 member ring. So let us make two 6 member ring. Are you getting? Now here you have one carbon number. So this is 1. So 6 is here. So let us say 1, 2, and this is 3, this is 4, this is 5, and this is 6. On carbon number 5 you have a carbonyl group. On carbon number 1 you will have CO. And this OMe, so if I lose this OMe, so this comes back, or if you wish I can write in two steps. So OMe is there and O minus is there. Are you getting? And carbon number 6 that contains a CH3 group. Now what happens? This goes here and this OMe leaves. Same thing I am writing in two steps. So you will have the final product something like this. So here you have a double bond O, and now this side you have double bond O, and there is a 1 methyl group. So this is a product after Claisen. So this is not a part of the answer. So this is basically wrong. So I think all of you have copied this one. Now let us write the next one. Same thing, we have to write product after Claisen condensation. So let us discuss C part. So this says, this time we have CH3. So let me make something like this. So you have 1 2 3 4 carbon and CO connected. So I have, so let me use the bond line diagram. So I have 1 2 3 4. So let us say I have a CO group here, and then I have 4 carbon in the middle, 1 2 3 4, and then on carbon number 5th, so 1 2 3, I have again CO group. So carbon number 5 also contains CO, and this side I have OMe, and this side I have CH2 CH3. So this is the compound. Now once again OMe minus is acting as a base, and the solvent is CH3OH, and we have to write down the product in this case. Now once again this is example of intramolecular aldol condensation, and this will result in intramolecular Claisen condensation, and this is also called Dieckmann condensation. So intramolecular Claisen condensation has a special name, and that is called Dieckmann condensation. Are you getting? So this is a basic example of Dieckmann condensation. So this is an example of Dieckmann condensation. Are you getting? So now what can you do is you have to leave this group. Now this carbon can be treated as alpha carbon, or this carbon can be treated as alpha carbon. So if you attack this carbon on this carbon, you will have 1 2 3 4 5 member ring. Are you getting? So if you connect this carbon to this carbon, you will have 1 2 3 4 5 member ring. Now if you connect this carbon, you will have so this carbon to this carbon. So if you connect this carbon to this carbon, are you getting? You will have 1 2 3 4 5 6 7 member ring. Are you getting? Now you have two options. Either you can make 5 member ring or you can make 7 member ring. Generally 5 member ring is preferred over 7 member ring. So 5 member ring is more stable than 7 member. So we will make 5 member ring in this case. So that is if I follow the first step. So let me write again. So I have this, and then this OMe. Are you getting? Now what I can do is, so let us make a carbon ion. So if I take H plus, I will have a carbon ion, and this attacks here, this opens, and then in the next step goes. So I will have a 5 member ring. So let me make fast. So let us number this one. I have 1 2 3 4 5. So I have to make a 5 member ring. Let us first make a 5 member ring, and carbon number 5 contains C double bond O. So let us call this the carbon number 5. This contains C double bond O. So this is carbon number 5. So this will be, I can write 4 3 2 1, 4 3 2 1. So this is carbon number 1. Carbon number 1 will contain CO, so this will contain CO, and then this side you have CH2 CH3. Are you getting? So this is the final product of this reaction. Of course this is intramolecular Claisen condensation. Of course it's also called Dieckmann condensation. So let us say D part of the question you have. So this time you have this molecule plus OMe and then CO, C double bond O, and this side OMe, and then again you are taking OMe minus, that is the base, in solvent CH3OH. You have to write down the product in this case. So what can you do? You can make a carbon ion from here and attack here and lose this group. So what you will do, you will make a carbon ion and this carbon. So this is alpha hydrogen, so make a carbon ion here. And then in the next step you lose, so you attack here. And this goes up, this goes down, so I can connect these two things. So let me write the final product, because there is no use to writing the same thing again and again. So you will have CO, and this side you will have CO, OMe. Are you getting? If you take this is in excess, you can also attack next time. Are you getting? So if I take this is in excess, in that case, yeah, you have to remove this OMe also. But if it's not, nothing is said, you can simply remove one molecule, one leaving group, one OMe. If I say this is in excess, in that case you have to remove this one also. So now let us do E part. So this says I have a 5-member ring, and then this side you have CH2 and COOET. Here also I have same thing, CH2, COOET. Now this time the base is OET minus, and ETOH is acting as a solvent. So you have to write down the product in this case. So what you will do? Oh, I am sorry, this is CH3, not OET. So this is CH3. So what you will do this time? So let me write. So you can follow yourself. So this is a CH2, then CO, OET. Now here you have CH2, and then CO, and then you have CH3. So this carbon is alpha carbon. I can make CH2 minus carbon ion, and this carbon ion will attack here, and this goes up. So we will have a 1 5-membered and 1 6-membered ring. Are you getting? So this attacks here. So this will be 1 2 3 4 5 6-membered ring. So this side you have a 5-membered ring, and this side you have a 6-membered ring. So this side you have a 5-membered ring, and then this side you will have a 6-membered ring. Are you getting? So this side will have a 6-membered ring, and this carbon, that is a carbon connected to this carbon, and this carbon will have basically C double bond O, and this is CH2, and then you will again have C double bond O. So you are getting a diketone in this case. So final product is diketone. Are you getting or not? So copy this one fast. We'll discuss the next problem. So you see, in these following reactions, what we have done is, we have generated a carbon ion, and this carbon ion attacks on one molecule, and there is a leaving group. So I leave that leaving group, and the final product sometime we write just by adding, like in case of intramolecular. So you can have intramolecular condensation, or you can also have a intermolecular condensation. So there are two processes. Generally, intramolecular condensation is faster than intermolecular condensation. We'll discuss the next reactions.